function is a set of input values x that associate with a single output of a set of values y. So for right now, I'm just going to talk about the basic idea of a function, just what a function is, why do we care about them so much, and just how to approach functions. I mean, functions aren't really that hard to understand. What is hard to understand, or what people are... I remember when I was in the class, I just said, well, why do I care about functions? Who cares? I'm going to try to explain why people do care about functions. So let's talk about the basic idea first. So the basic idea of a function is, for every x, there can only be one y. So let's put up a few sets of numbers. So let's say I have the numbers, let's say I have x and y values, and let's say I have 1, 2, 3, 4, and 5. And over here I have 11, 12, 13, 14, 15. So what this says up here is that for our x values, they can only associate with a single y value in order for it to be a function. So let's say one associated with 11, one associated with 2 associated with 12, 3, 13, 4, 14, and 5, 15. So this is a function because if I put 1 in my function, I'm going to get 11. If I put 2 in my function or equation, you can just think of it as an equation for now. So if I have an equation and I put 1 in, I'm going to get 11. If I put 2 in, I'm going to get 12. If I put 3 in, I'm going to get 13, 4, 14, 5, 15. So this is a function. And again, it's because this x has 1y, this x has 1y, this x has 1y, this x has 1y, etc. So let's do something that's not a function. So let's say x, y, and let's say I have the same set. 1, 2, 3, 4, 5, 11, 12, 13, 14, and 15. Let's say 1 goes with 11, 2 goes with 12, 2 goes with 13, 3 goes with 14, 4 goes with 15, and 5 goes with 13. So if I put in 1 into my equation, I get 11. So that's fine. So 1x, 1y. If I put in 2, though, I get 12 and 13. So imagine you have an equation, you put in 2, and then for your answer, you get 12 and 13. So you have something that's giving you more than one value. So this is what's making it not a function. 3 goes to 14, that's fine. 4 goes to 15, that's fine. 5 goes to 13, that's fine. 5 has one value, 4 has one value, 3 has one value. So the only thing really that you have to look out for if you want to identify whether something is a function or not is just to see if it has more than one value. And it doesn't even have to be a set of numbers. Functions can be anything. I could just have, let's say I have just x, y, and just say I have stuff, 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 and stuff. And over here I have other stuff, other stuff, other stuff. And let's say it corresponded like this. So let's say, or this can be stuff 1, stuff 2, stuff 3, and stuff 4. So let's say stuff 1 goes with other stuff. Stuff 2 goes with other stuff. And stuff 3 goes with the same other stuff right here. And then stuff 4 goes with that other stuff and this other stuff. So let's find out if this is a function. Stuff goes with other stuff, that's fine. Stuff goes with others, just one thing of other stuff, that's fine. I'm checking them over here, that's fine. 3, stuff goes with other stuff. It doesn't matter that it's the same stuff, as long as it's just one stuff. There we go. And then this one goes with 2 other stuffs. So this is going to make it not a function. So now that we have the basic idea of what a function is. A function means that we have one, so if we put in some input, we get only one output. So we have one input, one in, one out. That's how a function works. You get one value goes in, one comes out. If you have two values that come out, then it's not a function. So that's not really the confusing part. What ends up confusing people is not really trying to understand, okay, one thing goes in, one thing comes out. That's pretty easy to understand. What ends up confusing people is why it's important or why does it matter. And the reason that it matters is because later on, a lot of the math, all of our math that we're going to be learning is going to be based on the fact that the equation that we're dealing with is a function. Because if it's not a function, things like that we learn in calculus and things like that, it won't work. And the reason that's important is because in chemistry and physics, all of our equations come from calculus and differential equations. And differential equation is just a branch of calculus. So if something's not a function, calculus won't work, and we're not able to get a lot of our math that we use to do all kinds of science with. And there are certain fields of math that deal with things that are not functions, but there aren't very many applications for things that are not functions because, I mean, the only thing I can think of offhand is particle physics or quantum physics. And it's hard to tell whether it's more because it's they don't understand enough of it. It's just a field that's very hard to study. So, I mean, the main reason that we end up dealing with functions, let me talk about it like this. The main reason we end up dealing with functions is because in math, what we're trying to do is just model the universe, trying to come up with different equations that match the universe. That's the whole point of math. I mean, no one's out here doing math for fun, or at least most people aren't. I don't know, it's a little bit fun, but most people are not here doing math because it's fun. The reason that math was invented is because it's a useful tool. It's like a hammer or a saw, but it's just it's a tool for something more abstract. It's just another tool in the tool shed. So the reason that we use functions is because the universe acts like a function itself. The universe behaves in a predictable manner. The universe behaves very much like action-reaction. For every action in the universe, there's only one possible reaction. So let me do an example. So let's say I have a box. Or actually, let me use my box tool. There we go. So let's say I have a box. And it's on a table. So this box is, hold on, let me scroll down so it has the illusion of being on a table. So let's say this is a box on a table. And I'm going to push it. I'm going to push it with X force. It's going to go, let's say it goes 5 feet. Now let's say I move my box back again. So let's say I move my box back. So I move my box back to my starting location and I do X force again. How far is it going to go? It's going to go 5 feet and nothing else. It's not, I mean, and I can keep doing this forever and ever. I'm going to move it back again. And then I push it with X force again. And it's again going to go 5 feet. It's always going to go 5 feet. So that's what I'm saying. For every input, there is only one possible output. I'm not going to push it with X force. Let's say I push it, I'm not going to push it with X force and then have it go 20, let's say 10 feet. That's never going to happen. If I push it with the same amount of force on the exact same surface, if all of my conditions are exactly the same, it will continue to go 5 feet, 5 feet, 5 feet. It will never do anything else. Because the universe behaves like very much like a function. It has certain cosmological constants. It has just a certain set of values where everything must behave in a certain way inside of it. So that's why a lot of our math is based off of functions, because everything operates like a function. If if it didn't operate like a function, let's say we got two values. Let's go down again. So let's say I had another box, but let's this time assume that I'm in a universe. Let's say I'm in a universe that is not a function. So if I push, in this universe that's not a function, if I push x force, what I'm going to get, I might get 5 feet, but I also get 10 feet. So I get two answers. I push x force and I get 5, and it goes 5 feet and 10 feet at the same time. Now, I don't exactly know what a universe would look like that. If you really want to, if you're interested in that sort of things, you want to talk to a theoretical physicist or a cosmologist like Stephen Hawking. You want to talk to someone like that. I don't really, I know a little bit about this, but I don't really feel comfortable explaining, and it's not really part of this topic anyway. We don't really need to talk about this in algebra anyways, but that's what this would mean. And our universe does not behave like this. It doesn't behave like this. It behaves like this. Input is equal to some output, some output. One output. I don't do something in the universe and then have two different things happen. It has one thing happen, and it happens every time. It happens predictably. If I drop something on the ground, it's going to take the same amount of, it's like Newton's apple. If it falls from the tree, and it's going to take the same amount of time for it to fall. It falls predictably. It doesn't sometimes go in super slow motion to the ground or really fast. It behaves predictably. So that's why functions are important, because everything in the universe behaves in an action-reaction, input-output. And in fact, you couldn't be alive if the universe was not like this. To say, your body it's very, very intricate, and everything has to be in such a way where you have messenger RNAs going out to different places, proteins. If it didn't act predictably, you just couldn't be alive, because things would happen. That's the whole point. It needs to be predictable in order for things to happen. It's like this computer you're looking at right now. If it didn't operate predictably and things just turned on and off sometimes, or two things happened at once, nothing would ever work. Nothing in the universe would work. So that's what I mean. Everything in the universe operates predictably, input, output. So anyways, now that we've been talking about that for a long time, now I hope you understand the reason why functions are so important and why we even start talking about them, because you're not really going to understand why they're useful or why we're even using them. Why do we even care about them until you get to those later classes? So I hope this is sort of like a heads up on why it's important. I guess let me do one more example in case you didn't get those examples. Let's say I have actually this reminds me. I have a bird problem. Let's see. I have a car. Let me do one more example in case you didn't understand that. Everyone will understand this. I have a car, and there's a tree that's by it. And there's some bird that always just craps on it. Let me see. Now, some days there's more crap than others. And the amount of crap on my car is a function of how much, let's say there's some old guy in the park throwing seeds on the ground. So I have this bird, he goes over and eats the seeds, and the amount of bird crap in my car is a function of how many bird seeds he eats. So if he eats 20 bird seeds, I'm going to get 20 bird seeds worth of bird crap in my car. If he eats 10 bird seeds, I'm going to get 10 bird seeds worth of bird crap in my car. He doesn't eat 20 bird seeds and then give me 50 bird seeds worth of bird crap, although sometimes it does seem like that's the case, but I'm pretty sure it's not. But that's another example of a function. The function, the amount of bird crap on my car, well, I haven't really introduced function notation, but I would write a function for the bird crap on my car. Yeah, there's a lot. There's like that much. So that's another example of a function. Like I said, the amount, there's only one value for every amount of, there's only one possibility, there's only one amount of bird crap for every amount of bird seeds this bird eats. So that's another example of, so where x would be bird seeds, my y is bird crap. And for every x, there's only one value of bird crap. So if he eats one seed, he's going to have one seed's worth of bird crap. If there's going to be 2 seeds, then there's 2 seeds worth of bird crap. So I hope this makes sense to you. And if you still don't get it, because sometimes it's a little bit bizarre to think about in the beginning. I mean, I remember when I was first learning about it, I got it, but I was just weirded out by it, to be honest. It's a little bit weird. So if people are still having trouble understanding the general idea of what a function is, let me know, and I'll try to explain it another way. I'll make another response, but let me know if you need an alternate explanation. Post a video response on my video response page.